welcome to another session on compute network. So today's session we are going discussing about which is a carrier sense multiple access. So what is meant by this a carrier sense multiple access mechanism? So in this session we are going discussing about in depth of the carrier sense multiple access mechanism, which is going to helpful to allocate the channels if a number of customers are available. So think it this way: if we allocating as if one particular bandwidth, if n number of customers are increases, right? So how we are able to segregate this bandwidth into n number of channels, how we are able to partition, and how we are able to assign each and every channel to the respective users, we are going to discuss in this session that we are calling as a carrier sense multiple channel allocation. So here the carrier sense multiple access, which ensures that the fewer collision at the station, which requires when the first sends the carrier before transmit data. So if it is ideal, then sends the data, otherwise the channel will wait until it becomes ideal. So understand this way. So we have two stations are there. One is we having a source station, another one we having as a destination station. So we are able to request information, we are able to transmit information from source to destination. So first we need to check what is the status of my receiver position, the destination position. If the destination status is available, which means it should be in ideal state condition, then we have to initiate the process of this transmission. So the channel is available, the signal transmission rate is high. So channel is successfully transmission, there is no chance of this signal collision. That is the reason we calling as it ensures the fewer collision of data transmission from source to destination. If we think it this way, if the channel is not ideal, the channel is in busy state, so we are not initiate the signal transmission process. We have to wait until the signal should be in ideal position. So which means we have to continuously raise the request when we get the notify the signal should be ideal, the destination channel should be ideal. If we get the response from the destination channel, if the signal is ideal, the channel is ideal, then only we start the initiation process. That we calling as a carrier sense multiple access mechanism. So in the carrier sense multiple access mechanism, we have three types of protocols are there. One is one persistent CSMA mechanism, non-persistent CSMA mechanism, and p-persistent CSMA mechanism. So in the next upcoming slides, we are going discussing about in depth of this each and every protocol. So first one is one persistent CSMA channel. So if we see this one, when the channel is signal transmission from source to destination, assume that one we having as a signal transmission from source to destination. So if we need to check the status value, if the channel is ideal, so when check the source and destination position, the status of the destination position, the channel is in ideal mode, then only we can able to the station should be transmit data. Otherwise it should be wait for random amount of time. If it should be in busy state, it has to wait for the some amount of time. Again we go for this the request for channel allocation. So how we are able to allocate that one? So we are able to continuously monitor continuously sense the signal position, continuously sense the channel position, the status of the destination channel position. If the destination channel is busy, so we continuously monitor that one, which means we have to carrier sense, we have to sense the mechanism of the destination status channel. If the status channel is busy mode, we have to wait the random amount of time. So until the status we get ideal position, then only in the ideal status domain only we are able to initiate the process of this transmission. That we calling as a one persistent transmission of information. We calling as a I persistent or one persistent of carrier sense multiple access mechanism. And similarly, the second one is we calling as a non-persistent CSM mechanism. So in the previously we are continuously monitor the signal position value, the channel position value. But here what happened? First we have to initiate the response. The channel is busy, so we have to wait random amount of time. If in this time duration still the status is busy, so again we wait for random amount of time, again we initiate the request. So previously we have to continuously monitor, continuously raise the request in the channel position, but here we have to wait. Once we sense the channel is busy, we have to wait the random amount of time, then only again we raise a request. We have to sense the channel position. Still the channel is busy, we have to wait some amount of time. Until we get the channel is ideal, then we can able to initiate the signal transmission process. When you see this one here, the channel state value, if the channel is in ideal mode, then we can able to start the transmission. If it is in busy mode, we have to wait the random amount of time. Then only again we raise a request. On the time channel is busy, channel is ideal, then we initiate the process. And if even though we wait random amount of time, the channel is still busy, again we have to wait the some amount of time. Then that we calling as a non-persistent CSMA mechanism. And the persistent CSMA mechanism. So when you see this one, the persistent CSMA mechanism. So when you see this one, in the channel is in busy state. So channel in busy state, it acts through the collision which occurred and start again process. When you see, probably channel is in ideal mode. When sends the channel process, channel in ideal mode, the probability time output is very less, which is less than or is equal to the probability of time value. But if the channel is in busy mode, again we redirect the channel status. When the channel is ideal amount of time, we wait a slotted amount of time which value is greater than of my persistent time. When you see this one, we have continuously sense the signal value. The channel is in busy mode, we have to wait the time slot duration value. This probability outcome, which means we are does not able to transmit the information from source to destination. We have to wait this slotted amount of time, the respective amount of slot time. So that values must be greater than the p value. If the channel is in ideal mode, then only we start the initiation process, or else we have to wait the again some amount of random time. So we have to wait again and again the same time slot value until we get the channel is ideal position. So this is with help of this mechanism, we can able to say a carrier sense multiple access mechanism is having as a less kind of signal collision, but it may have a chance of signal collision, but due to we follow this type of situation, we have less types of signal collision should be happens. So amount of information is successfully transmitted. So when you see this one, the comparison perspective of the CSMA mechanism. So what is the throughputs? When you see the comparison throughputs of the CSMA mechanism, the channel signal transmission rate. So when you see the transmission attempts per a frame time, when we compare the throughput for frame time. So when you see this one, we have the previous slides in the previous session discussing about this pure aloha and slot aloha value. When you see the time slot duration value, the throughput values, which is g into e power minus 2g and g into e power g. So but when you see this one, here the persistent of value, which is p persistent, 1 persistent, non-persistent, the value is apparently which is 0.1, 0.1 and 0.0.1. So which is apparently we having is high amount of signal collision is reducing. So that is the needed of when the signal transmission from source to destination. If the signal collision is very less, so we can able to transmit the signal accurately, so we can receive the signal proper manner. And if any signal collision should be happens, so how we are able to detect that one? So that is the process we calling as a carrier sense multiple access with collision detection. The carrier sense multiple access, we are able to reduce detection value, collision detection value, but it having some kind of probability of collision detection. So we having as a one mechanism which we calling as a carrier sense multiple access with collision detection. So here we are able to analyze the collision value. If any detection should be happens, we are going to detect in this value. So here the station can terminate if data is collisions. Assume that one. We are going to transmit the information from one frame by frame. If any collision should be happens, so the transmission should be break. The transmission should be terminated. So for example, I am going to transmit this information from source to destination. The frame 1 is successfully transmitted and the channel is ideal. Frame 1 is transmitted. The channel is still in ideal position. The frame 2 is transmitted. So even I am check this channel is ideal, but I can transmit the frame 3. But same time some other information also transmit the frame 3. So here even when I check this time, the channel is ideal. This person has checked the time, that is also channel is ideal. We both are transmit the information, transmit the frame at same time. So the frames are received the same position, same time values only. So both are should be happens of collision. So on the situation, this transmission should be terminated. We go for this retransmission process. How it happen? Based upon the respective T0 time slot value and the respective contention window slots values only. So if this collision should be happens, so based upon the ideal period value ideal period value, there is no collision should be happens. If in busy state value, multiple channels are signal transmitted, it may having as a chance of collision detection. On that time, the signal should be, the source should be, and the destination should be initiate the process of this termination of transmission. We again go for this retransmission of the same frame. So, but how we are able to avoid the collision? That process we calling as a carrier sense multiple access with collision detection. So, how we are able to analyze this value? So, if we are continuously sense the value, if continuously monitor the value, so the process with avoid the collision, once we detect the collision and sender is receiving the acknowledgement. If any collision should be happens, sender receives the acknowledgement. If just one signal, then data is successfully sent. But if there are more than two channels or two signals, that means collision should be occurred. If collision should be occurred, the process should be terminated. That we calling as a collision detection. But how we are able to avoid the value? If once we collision detection, the signal is sent the receiver is sent the acknowledgement to the source. So we are waiting again for continuous of signal status values only, the channel status values only. Channel is still busy. We have to wait the some interframe space amount of time, some random amount of time. We apparently we calling as a interframe space amount of time. We have to wait that amount of time, and we have to we have to check the size of binary exponential. We calling as a contention window mechanism. So the time slot of this window mechanism is ideal after the frame space dot value. Then we are able to send the information. Then after successful receiving, there should be timeout should be happens. So based upon this one, we are able to avoid the collision. But when we avoid the collision value, what kind of things we are using that one? We are using this interference space value, contention window value, and acknowledgement value. So think it this way: the frame 1 is successfully transmitted, the source station is there as well as destination station is there. So the frame 1 is successfully transmitted. If any collision should be happens, we have to wait some intermediate frame space time based upon the window size, which is the contention window size value. Based upon the contention window size value, after this period of amount of time, after this started amount of time, if the channel is in ideal position, why we get in this one? Because the channel is busy state, so we get the channel collision happens. After this collision happens, which means the status is busy, so we have to wait some interference space amount of time, the contention window amount of time. We have to wait that time, and we have to check the channel status. If it is ideal, we initiate the signal transmission process. Once the channel is successfully transmitted, we get a positive acknowledgement, which means we are successfully transmit the information from source to destination. So these are the things which we involved in the collision avoidance process, so we can able to reduce the collision from source to destination. I conclude this session. In this session, we are going to discuss about the carrier sense multiple access mechanism. We done the discussion on a carrier sense multiple access, which means how it works and what kind of protocols we are using to implementing this carrier sense multiple access mechanism. And in the next session, we are going discussing about the Bluetooth process. So in this session, in the Bluetooth mechanism, so what is Bluetooth, how it works? So generally everyone usage of this Bluetooth mechanism. So when you go for this mobile to mobile Bluetooth transmission is there, or else the interframe network, like we are using a Bluetooth communication and a Wi-Fi dongle kind of services, we are going to interconnect with our wireless keyboard or wireless mode. We are going to interconnect with the Bluetooth devices. How we are able to sync up with the devices and how it works, we discuss in the next session.